Let's graph 2 periods of f of x equals minus 5 sine of 3x minus pi plus 2. All right, so we have a sinusoidal function in the format of a times sine bx plus c plus d. And we remember that our amplitude is the absolute value of that number sitting out front. So this trig function is going to have an amplitude of 5. We can always find the period by taking the original period of our trig function and dividing by b. So I have here 2 pi over 3. Our phase shift is numerically this value divided by that one. I know I'm moving to the right, so it's going to be a positive phase shift. So I see a pi over 3. And here we see that c is actually minus pi. It's opposite c over b is what's published in our textbook. But I always kind of like to just think about what that means. I see that minus, I know that's a shift to the right, so my phase shift is positive. And then I have a vertical shift up, so a vertical translation of positive 2, meaning I'm going to move the graph up 2 units. All right, so I'm ready to start my graph. And so I want to start graphing at my phase shift, and I'll end graphing 1 period later. And so I can always find that starting and stopping point thinking about my phase shift being a starting point and what 1 period later does. So I need to think about the phase shift of pi thirds plus the period of 2 pi thirds. And well, that means this period is going to be ending out at pi. So let's see, that would be 2 pi thirds and pi is 3 pi thirds. So to scale something right around there. Now I need to know the value that's right between pi thirds and pi, and I could think about averaging them, but as I counted up there, 2 pi thirds was right in the middle. And now I need to know these tick marks right in the middle of those spots. And one way to do it is to take the period divided by 4 and add that value to find each of them. I like just finding middles of 2 spots, so I can think about averaging these numbers. So that's 3 pi over 3, or pi divided by 2 would be pi halves. And then just thinking about doing that again, I'd have 5 pi thirds divided by 2, which is 5 pi over 6. And that's enough information to get 1 period sketch, so I'm going to go on and do that much. I think I need my axis here to be a little taller. The vertical translation being 2 means my sine function here is going to weave around that line at y equals 2. And then I need to be able to go up 5 and down 5 from there. So 1, 2, 3, 4, 5 up at 7, and then down 5. 1, 2, 3, 4, 5 down there at minus 3. All right, so my first period of sine here. Sine starts on a center line and usually wants to go up, but that minus out front tells me I actually need to go down in amplitude, back to the center line, up its amplitude, and then down to its center line. And there's one nice happy period of the sine function. But I was asked for 2 periods and not told which way to go, so I could graph a period out here or a period back there. And I am just going to choose on this one for no real reason. Both would be appropriate to imagine going the opposite direction. And so if I think about it, I need to go 1 period that way. So 1 pi thirds minus the period of 2 pi thirds. I'll be ending at minus pi thirds, so about there. All right, and now I just need to think about where the middles of things are. Well, fortunately, right between a minus pi thirds and a positive pi thirds, I will have 0 as one of my key points. 1 pi 6. And minus pi 6 to round out my 5 special points. And now I just need to make another one of these downward sine shapes, that reflected sine shape. And there are 2 periods of y equals minus 5 sine of 3x minus pi plus 2.